Hello everyone, Kemi is my name and I welcome you to this YouTube channel. And today we want to learn how we can configure INTRA-AS MPLS. There are 3 VPN on our MikroTik devices. The MikroTik routers we are using for the purpose of this video is running version 7. And for INTRA-AS, this means that the end devices, that is our client, is connected to the same AS. We are running the same AS on all our devices. And from this topology that we have on our screen, this particular client has 2 sites. We label one as CE1 and the other site as CE2. That's just our own label. You can label it the way you prefer it, or how it's going to be, how you can remember the labeling. This is just a demo. So the site 1 is connected to R2, while the site 2 is connected to R4. R1, R2, R3, R4, and RR. These are the devices of the service provider. I like to call it the core network. So for you to run INTRA-AS on your MPLS circuit, you must have some prerequisites. Number 1 is that you must have an IGP running, and in our own case, OSPF is running on the core, as well as MPLS. So once you have an IGP and MPLS running on your core network or the core devices, then you can deploy the INTRA-AS. For you to now deploy the INTRA-AS, there are some parameters that you need to set, or some steps, 4 or 5 basically. The number 1 is that you need to configure VRF. You need to set a VRF on the PE. In our own case, R4 and R2 is the PE for this our deployment. So we are going to configure VRF on R4 and VRF on R2. We are also going to set up MP-BGP on our network as well, and that will run between the RR and R4 and the RR and R2. Also, we are going to run PECE routing protocol. That is the protocol that will connect the client to the core. In our own case, we are using OSPF. You can use static routes, you can use eBGP, you can use other forms of routing protocol to ensure the layer 3 connection between these your client and your core. But for this our demo, we are using OSPF. So let's get started. From R2, we configure our VRF, virtual. So to do that, on MikroTik router, particularly running version 7, click on IP, click on VRF, then click on plus. You can give it a name. I like to label it as to a particular client. Let me say CE1. Then interface. For this interface, we are going to select the one that is facing the client, the one that your client is connected to. It can be a physical interface and can also be a VLAN interface. So we are running this on ETA 10. Apply. So we have completed the first step by configuring a VRF on our core network. So the next router, that should be R4. The same step, IP, VRF, and add. Then interface, ETA 10 as well. So we are through with the first step. Now we go to the next step by setting up our MP-BGP. That's a multi-protocol BGP, and this connection will be between the RR and R2 as well as the RR and R4. We are using this setup because we don't have a full mesh, an IBGP. Yeah, that's the term I'm looking for. An IBGP full mesh connectivity between the core devices. So that's why we are making use of a route reflector to ensure that R2 and R4 are connected. So the RR is like the middleman connecting R2 and R4, because BGP does not permit, it has scalability issue. So hardly do you have a full mesh BGP circuit, and that is why one of the ways of ensuring that all your devices are connected if you are running BGP is to use a route reflector. In our own case, because we are running IBGP, because there are two versions of BGP, you have the IBGP and the eBGP. The IBGP runs between devices that are in the same domain, while the eBGP runs between devices that are in different domain. In fact, it is through eBGP that the internet is being made possible. So to set up your MP-BGP to set up your MP-BGP in this particular circuit, we start from the route reflector, the device that we label as RR, because we are going to pair it with R2 and R4. And to achieve that, we go to the routing menu and to the BGP submenu. We start from this connection. We can set up a template, but because we have a very small circuit, so we can start from, we just go straight to our template. So I can label this as to R2. Then the AS that I've designated is 100. Then you can select the address family. Because we are running a VPN version 4, I need to check this. I can also check this one, but we are particular about this because in the future we are still going to run all these address family. So even though I did not enable it here today, it is still possible that I'm going to enable it in the future. But if you even leave it enabled, it doesn't cause any harm. So our router ID, I normally use the loopback address as the router ID. Then the remote address, since I'm going to R2, I'll do that using the loopback address as well. They are in the same AS. So and the role of this is a route reflector, and this is the value I'm going to choose. So I'll just copy this and just change it for R4. I need to change the remote address as well. So okay, to enable connect and listen. So I have to go to R2 and R4 and do the same. So loopback address of the route reflector. So the role of this is the client, IBGP RR client, route reflector client, enable connect, enable listen. So let me reconfirm. So check the session, it has connected. So I have the IBGP running between the reflector and R2. So I repeat the same system, the same process for R4. So that has been completed as well. So the next step now is to run a PECE layer 3 connectivity, that is between the device at our core and the client device. So to do that, since I'm running OSPF, I'll start from R2. So this should have, okay, just give it some minutes, it will connect. So from R2, I'm running I want to run OSPF between my R4 and my client device. I mean the R2 and the first site of the client. So I'll go to the OSPF menu. I'll create an instance for that. Let me label it as this. Then the VRF that I've created, my router ID, I can still maintain the same loopback address. Then I go to the redistribute section. I'm redistributing the connected routes into this. So I'll choose these two options for that. So after creating the instance, I'll create an area. Let me label it as this, and the instance. Basically, just a basic information. Then I go to my interface template. Okay, I think I've done it before. Let me just repeat it. So this network 0.2. That's just all basically. So I'll do the same thing on R4. OSPF, that should be C2. The VRF is created one, router ID. And I redistribute. So I'm through with the PEC configuration, particularly at the PE end. I'll still need to go and do the one at the C end as well, but that'll be the last step to take. So okay, now to do the VPN configuration, the BGP VPN configuration, from R2, I'll go to my routing, the BGP, and click on the VPN. So these are the parameters I need to configure my route distinguisher. I'll use my loopback address and colon, being the first client 1, on which VRF, that's its own routing table. That's the one. This will be value for this will be per VRF. Then import route targets. I use the for me to understand, I do use the layman language. Import what I'm receiving, then export what I'm sending out. For my topology, I'm receiving from router 4, so I like to call it 4:1, being the first client, and then I'm sending out 2:1. Then I'll come to my redistribute section as well. So I'm redistributing this BGP into OSPF. I'm also redistributing the connected routes. So I just repeat the same thing on R4 as well. Come to routing, BGP, VPN, click add. Here is run 1, my VRF for this client, the label allocation policy by VRF, import route targets. This is one I'm receiving from router 2. Then my export, what I'm sending out for this particular design. Then the redistribute connected and OSPF. Then for the client's end, I've already done the OSPF configuration. This is client 1. Just the OSPF configuration alone. So I've done it already. Also for the CE2. So from the first site, that's CE1, you can already see that it is receiving routes from via OSPF from the other end. The LAN of the other end is 4.4.4.0/24, and this is the IP between this 172.0.4. This is IP between the core device and the client's device. So on this particular CE1, it is receiving routes. That means that there is connectivity already. Just to confirm, let's go to CE2. This also has already will be receiving routes. Let's go to the routing table already. Yeah, and the IP configuration for the LAN, I use 4.4.4.1, which we were seeing on CE1, and this is the IP connecting these clients to the core. So it is through OSPF that the LAN on or the network of CE2 communicates with CE1. So you can do a ping test. I'm on CE2, so that should be 2.2.2.1. So it is reachable. On a core network, to do some certain verification, just go to the route and specify the routing table. IP route. At this column, specify the routing table that you created. It will display the routes that are available. As we can see on our screen. So which means that we have successfully set up INTRA-AS MPLS layer 3 between CE1 and CE2. CE means customer equipment, PE that's the provider's equipment. So this is how you carry out this. Very simple to do with MikroTik, straightforward, and you don't have any issue. So I want to thank everyone that has taken time to watch this video. Please learn more and grow more. I also want to encourage us and appeal as well that we should subscribe, we should like, and we should share this video so that we can have more network engineers in the whole wide world, because we are actually what others are resting on. Even though we have a lot of software, a lot of applications, but all these applications needs network to run. So that is our work, and that's what we do. So I also want to use this opportunity that you can reach out to us on our numbers appearing on the screen. If you have any issue relating with your network, maybe you want to do a setup, you want to troubleshoot, you want to manage, or you want to maintain, kindly reach out to us. We are available for consultancy services as well. We are also into other aspects of this ICT. We do UI UX design, we do web design, we do security. It's like a total package. Just reach out to us, let us know how we can help you. Thank you very much. I hope to see us